use the change of variables theorem to compute the following double integral. So we have this integrand here, 4x plus 8y, with respect to this region, which is a parallelogram with vertices -1, 3, that's a, 1, -3, 3, 1, 3, -1, and 1, 5. This is not a nice region, so integration is complicated. That's why we make some substitutions. Here are the substitutions. X is given by 1/4 quantity u plus v, and y is 1/4 v minus 3u. So the whole idea here is we have a region in the xy plane. Now with these substitutions we get a nicer region in uv plane. Okay, so to transform this into uv plane, we're gonna use these vertices with these transformations or substitutions. These are xy points given, so we need to convert into uv, but the transformations are given in terms of x and y, so we need to solve these two equations in terms of u and v. So x equals 1/4 u plus v is same as, let me use different color here, this is same as 4x equals u plus v, and here 4y equals v minus 3u. I'm trying to solve these two equations for u and v. Plus b, here is another plus b. If I subtract, we need to change signs, so negative, negative, positive, v and negative v cancel, u plus 3u, that's 4u equals 4x minus 4y. Divide by 4 throughout, u equals x minus y. Okay, let's plug this into one of these equations. 4x equals u plus b, 4x equals u plus v. U is x minus y plus v. Okay, isolate v here, subtract x, add y, 4x minus x, 3x plus y. So v equals 3x plus y. Okay, so we have these two new equations. Now let's try to convert these points, okay, these 4 points here given here, into uv plane. Let me draw a table. X, y coordinates we are converting into uv. The given points -1, 3, 1, -3, 3, -1, 1, 5. Use these two new formulas to convert into uv. So x equals -1, 3. Plug in here 1, that's -1 minus 3, so -4. V is here 3 times -1, -3 plus 3, 0. 1, -3, 1 minus -3, 4, -3, 3 times -3, -9, sorry, 1, -3, 1, 3 times 1, 3 plus -3, 0. And similarly x, y, plug in here and here, you get 4, 8, and you get -4, 8 here. So we have a new region. Let me draw that. -4, 0. So here is -4, 0, 4, 0, 4, 8, 4 all the way 8. It does not have to be exact, so this is 8 and -4, 8 somewhere here. So we have a, in fact we have a rectangle. Okay, 4, 8. Okay, now we need to find the Jacobian to compare the areas of these two. Okay, so what we have to do is we are trying to convert xy coordinates into uv. So xy is into uv goes on the bottom. This is given by parcel of x with respect to u with respect to v, parcel of y with respect to u with respect to v. And do we have x equals something? Yeah, we have here. If they were not given, x and y are not given, suppose we had given just u and v, we could find the reciprocal of this, del uv on the top, xy on the bottom, and later to find this, that will be reciprocal of whatever we found earlier. But in this case, x equals y equals given, so it's easy. So x parcel with respect to u, this is 1/4 u plus 1/4 v, so both 1/4. With respect to u, that's -3/4, and this is 1/4. Let's multiply 1/16 minus this is negative, so plus 3/16, so 4/16, that means 1/4. So the old area is 1/4 of new area, all that means. Or in other words, the area of this new region will be 4 times as bigger than the previous. Okay, then we can write the double integral in the previous region, that was r, I think. They have given r. We can call the new region as just say new d, doesn't matter. And what is the question? 4x plus 8y. Okay, x plus 8y dA. Okay, that is equal to, now we are in new region D. Now we need to write x equals in terms of uv and y equals in terms of uv. So x is in fact 1/4 u plus v, so this is 4 times 1/4 u plus v is just u plus v plus 8 times y. 8 times y, y is 1/4 v minus 3u, so 8 means that, let's multiply by 8, so 4 goes twice, so 2v minus 6u times the absolute value of Jacobian, which is 1/4. 1/4, the absolute value is 1/4 dA in this new region. So this is nice enough. So this is in fact a rectangle, so you don't have to worry, we don't have to worry about making it type 1 or type 2. And we know the double integral, let's simplify, u minus 6u negative 5u plus 3v. This 1/4 we can pull all the way outside. In fact, dA we can write now du dv or dv du, same thing. And looking at here, so v is outer, so v equals, in this case this is u and vertical is v, so v goes from where? Here 0 through 8. And how about u? U goes from -4 to 4. Okay, now this should be easy. 1/4, let's integrate inside, so v from 0 to 8, antiderivative of this with respect to u, so -5u is -5u square over 2 plus 3v is constant, so 3vu, -4 to 4, this is u equals, by the way, dv. And now this is 1/4 outside, 0 to 8. Let's plug in upper limit. For u, so u square 16 to 8, so negative 40 plus u equals 4 times 3, 12b, so upper limit minus, now you can easily do this part, okay, this is not difficult. Just do upper limit u equals 4 minus lower limit u equals negative 4, 40 negative positive 40 cancel, 12v plus 12v 24v, 4 goes 26 6 times, antiderivative of v is v square over 2, then upper limit lower limit you get 192. Final.